Hello students. In this video, we're going to explore the fascinating world of chemical reactions and equations, which are foundational concepts in understanding the changes that matter undergo. Let's begin by discussing what a chemical reaction is. A chemical reaction occurs when one or more substances, called reactants, undergo a transformation to form new substances, known as products. This transformation involves the rearrangement of atoms, leading to the formation of new bonds while old ones are broken. For example, when hydrogen gas reacts with oxygen gas, the atoms rearrange to form water. In this case, two molecules of hydrogen gas combine with one molecule of oxygen gas to produce two molecules of water. Now, how do we represent these reactions? That's where chemical equations come into play. A chemical equation is a symbolic way to describe a chemical reaction. It shows the reactants on the left-hand side, the products on the right-hand side, and an arrow pointing from reactants to products, indicating the direction of the reaction. However, it's important that these equations are balanced, meaning that the number of atoms for each element is the same on both sides of the equation. This follows the law of conservation of mass, which states that matter cannot be created or destroyed in a chemical reaction. Balancing an equation involves adjusting the coefficients, the numbers placed in front of the chemical formulas, so that the number of atoms for each element matches on both sides. Chemical reactions can be classified into several types based on the nature of the changes involved. One common type is a combination reaction, where two or more substances combine to form a single product. For instance, when calcium reacts with oxygen, it forms calcium oxide. On the other hand, a decomposition reaction involves a single compound breaking down into two or more simpler substances. This type of reaction often requires an input of energy, such as heat, light, or electricity. An example is the decomposition of calcium carbonate when heated, producing calcium oxide and carbon dioxide. We also have displacement reactions, where a more reactive element displaces a less reactive one from its compound. For example, when zinc is placed in a copper sulfate solution, zinc displaces copper, forming zinc sulfate and copper metal. This reaction occurs because zinc is more reactive than copper. A variation of this is the double displacement reaction, where ions are exchanged between two compounds, resulting in the formation of two new compounds. A common example is the reaction between silver nitrate and sodium chloride, which produces silver chloride and sodium nitrate. In this reaction, silver ions and chloride ions combine to form an insoluble white precipitate of silver chloride. Another important category is redox reactions, short for reduction-oxidation reactions. In a redox reaction, one substance loses electrons and undergoes oxidation while another gains electrons and undergoes reduction. A classic example is the reaction between hydrogen and copper oxide. In this reaction, hydrogen is oxidized to form water, while copper oxide is reduced to form copper metal. Chemical reactions can also be classified based on the energy changes that occur. Exothermic reactions release energy, usually in the form of heat, making the surroundings warmer. Combustion reactions, like the burning of magnesium in oxygen to form magnesium oxide, are exothermic. In contrast, endothermic reactions absorb energy from the surroundings, causing a drop in temperature. Photosynthesis is a prime example of an endothermic reaction, where plants absorb sunlight to convert carbon dioxide and water into glucose and oxygen. Finally, let's consider the real-world implications of chemical reactions, particularly oxidation reactions in everyday life. One common effect of oxidation is corrosion, where metals deteriorate due to reactions with oxygen and moisture. A well-known example is the rusting of iron, where iron reacts with oxygen and water to form iron oxide, weakening the metal over time. Similarly, copper develops a green patina when exposed to air and moisture due to the formation of copper carbonate. Another everyday example of oxidation is food spoilage. When fats and oils in food react with oxygen, they become rancid, leading to unpleasant tastes and odors. This is why food preservation techniques often aim to limit exposure to oxygen. Now, here's a question for you to test your knowledge. What is the type of reaction where energy is absorbed from the surroundings? Please share your answer in the comments. The complete curriculum for Class 10 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.